So there are other signs besides the temperature. For example, the sea has been rising relative to land around the world. There is geological evidence that suggests in the last 2,000 years the sea level relative to land, and this is a complicated measurement because continents move about, but essentially the increase was negligible. A small fraction of 1/10 of a millimeter per year, if at all. And in 1870 to 1890, when direct measurements were first being made, it was a very small increase, 0.6 millimeters a year. And in the last 18 years, it's gone up by a factor of 5. Now, what's a little bit disturbing about this is the rate of sea level rise is going up. It's beginning to exceed the predictions that climate scientists were making year 2000, 1990. So there's a 90% confidence level that the sea rise would have been between this dash line and that dash line, and we're right skating on the edge of the higher level. So it's increasing faster than we expected. It's because the glaciers around the world are melting faster than we expected. And this is the overall glacial melt from 1960 to 2000, and I think the last data is 2006 or 7. And as you notice, it's accelerating. So we're losing the world's glaciers, a significant portion of it. These numbers, let's say 2,000 or 2,000 cubic miles of ice. And so this is melting. There are numerous other examples of accelerated warming that I don't have time to go into. Because of this accelerated warming, the IPCC report of 2007 was saying that perhaps we could, in this century, go up by 0.7 meters, but now many of us are a little worried it could go up higher. It could be a meter or more. And so just in case you want to know where you can buy beachfront property, inexpensively, 1 meter rise in Florida is around here. This is a 4 feet rise around Louisiana and Texas. And so significant parts of the United States will be inundated. What about the fact that, okay, the climate's changing. What's the evidence that it was caused by humans? And so the evidence caused by humans is as follows. You consider all what we call natural variations. The sun actually goes through cycles of brightness, intensity. It varies. There are sunspots as well. There are things of that nature. There are massive volcanoes that actually have a cooling effect temporarily on the Earth. And these 3 gray bars point to giant eruptions that actually had a 1-year cooling period. You put all the natural variations into the climate models, and what you find is this black line is the observed increase, and you can't get the models to fit the increase. But if you put in the amount of carbon dioxide that we put into the atmosphere, and we know this is true not only because it's coincident with the beginning of the Industrial Revolution, but through actually isotopic abundance. When you dig up coal and oil that's been deep underground for millions to tens of millions to hundreds of millions of years, the radioactivity, the carbon-14 radioactivity, has long since diminished. And the change in the carbon in the atmosphere, we actually see a decreasing amount of radioactivity in the carbon. Carbon-14 is made by cosmic rays. There was a big blip upward when there was atmospheric testing, and that's subsided. And in this, we see this declining decrease. Now, the climate has changed in the past. And this is a record of the last 420,000 years. And lying on top of this is the temperature as measured from in ice sheets in the Antarctica. There's the amount of carbon dioxide in these long-lived glaciers and amount of methane. And the most striking thing about this is that when the temperature rises, the amount of carbon dioxide and amount of methane rise. So they're correlated. Now, it's safe to say that, for example, 50,000 years ago, or during this period here, humans had very little to cause to actually increase the temperature of the Earth. This is our present time. You can't blame this on Neanderthal man. But let me point at several observations. Number one, where we are at present time to the low periods in the ice ages is, this is 5, 5.5, this is a 4, 5, 6, 7 degree difference. The IPCC says if we continue as business as usual, there will be perhaps a 4, 4.5 degree difference. Their more recent MIT report says there'll be a 50% probability we will have cooled to more than 5 degrees difference. So we're talking about something, we're here in the middle of the ice ages. In the ice ages, the world was a different place. The United States, Canada, and the United States down to Pennsylvania and Ohio were covered year-round in glacier. So what you need to do is you need to imagine an equally different world that's 4, 5, 6 degrees hotter. And given the fact that the most responsible recent studies are saying there's a 50% chance we could go over 4.5 to 5 degrees centigrade, that means there's a 50% chance we will go into an equally different world, okay, if we continue business as usual. So those are the stakes. Now, what were those cycles due to? Excuse me, I can't help teaching some science, but it's kind of neat. This is the temperature record of the Earth. And this wiggle here is as the Earth goes around the sun, the eccentricity, but the most important thing is the tilt of the Earth relative to the sun. So if this is the sun, this is the Earth, this is the North Pole. During summertime, when the northern latitudes are getting more sunlight, things melt. And during the winter months, when the North Pole is pointing away from the sun as it revolves, things freeze up. And these are so-called Milankovitch cycles. This is Newtonian physics, so you can go back and tell the very subtle changes that actually alter the tilt of the Earth that seem to be very correlated with these spikes in temperature. You go back even further in time, and it continues. Now, we do not in detail understand why this tilt in orbit seems to be coincident with the temperature changes, because it's very subtle and it's very nonlinear. And so as climate scientists begin to try to understand these things, things change. But there are astronomical events that trigger it, but we don't understand the magnitude that they're triggering. The reaction of the Earth to these very slight changes is a lot bigger. So that just tells us the Earth is a little bit more sensitive than we thought. Okay, so here's the temperature cycles I just showed you, going back now 800,000 years. Here's our present time, where we're at this temperature. This is where the carbon dioxide, this is actually temperature and it's carbon dioxide, they're exactly the same. But now this is where we are in the amount of carbon dioxide in our atmosphere. And so we've actually exceeded anywhere we've been in the last 800,000 years, and with more indirect evidence over the last 2 million years. So we're in new territory. But just to show you what the stakes are, if we achieve and limit the amount of carbon growth so we only achieve 550 parts per million, the Kyoto target, we will be up here. And if we continue as business as usual, we will be here. So what that means is we're already off the scale in the last 1 or 2 million years, but we will be really off the scale, even in the best of outcomes. So again, this is something that gives you pause for thinking. Now, it's very hard to, with certainty, predict the future. That's something that Yogi Berra said countless times. Predictions are hard to make, especially about the future. So these are soft predictions. They may be 50% probability of happening, 80% probability of happening. No one's going to say on a regional basis that any prediction would be more accurate than 80, 90%. Okay. But with that caveat, it's not 10%. It's much higher than that.